Okay, this is concentrated solution of sugar and salt. This is a raw egg. Now I want you to put the raw egg slowly inside. Slowly. Inside. Okay, let go. Does it float or does it sink? It floats, right? Huh? Okay, very good. It floats. Now, it's floating because now the net density of the egg, net density means the total mass of the shell, the albumin, the yolk inside, plus a little bit of air space, all the total mass divided by the volume of the egg, okay, is less than, slightly less than the liquid, surrounding liquid step. So now, what we will do, let's look at the egg. And we pour in distilled water. Slowly we pour in distilled water from the top. As we pour in from the top, you will find that the top portion will be, the portion will be what? It will be, the top portion will be come on. The top portion will be dilute. So now it's more submerged, right? Yeah. Can you see? It's more submerged. So there will come a time where the egg is floating right in the middle. Right now. Huh? The egg is floating right in the middle. Meaning that with the liquid on top, with respect to the liquid on top, it is denser. The egg, the density of the egg is denser. With respect to the liquid below, it is less dense. So it is floating in the middle. And the fact that it's floating in the middle would imply that the density of the egg is exactly equal to the density of the liquid just beside it. Is that clear? And we call this buoyant egg. This is buoyant now. Huh? The egg is buoyant, floating. We call that we say that the egg is in neutral buoyancy. Now, neutral buoyancy is very important for fishes and submarine and scuba diver. Why? Because the fishes would like to swim at that level, right? It doesn't like to sink inside, right? So it like to swim at that level, see the scenery, catch the food and so on. So is the submarine. You know, submarine, they will descend to a certain level and stay there. Okay? And maybe it's just below the water where they stick the periscope up to see what's in the air. So is a scuba diver. If the scuba diver want to roam around to explore the coral reef at that level, at that depth, it will have to have a neutral buoyancy with respect to the surrounding water. Meaning that the density of the submarine, the fish, the scuba diver is the same as the surrounding liquid. Huh? That is, remember the word neutral buoyancy. How do you spell buoyancy?
Buoyancy.
Yes, right, that's buoyancy. Huh? And this is very, very, very important. Okay? Now, let's put this aside. And now, we have got this egg. Hold on to this egg. Hold on, let it go. And another egg. Now these two eggs are different, okay? Of course, one of them is colder than the rest. But how do I know which one is raw and which one is hard-boiled? If you look at this, how do I know? Assuming that you don't feel the temperature, how do I know or distinguish one is raw and the other is hard-boiled, meaning it's completely hard? You shake.
This one doesn't shake around.
This one doesn't shake around, and then?
This one seems to have liquid shaking around.
Oh, yeah. Oh, you shake, yeah. Okay, this is one way. Okay, this is one way. Is there another way to differentiate between a raw egg and a hard-boiled egg?
Put it in salt water.
Put it in salt water, it will be the same. Because the mass cannot change. The mass is all inside the shell, cannot change. Okay, this is something that you have not done. Spin it on this one. Cannot stand up, right? You spin it. Oh, this one cannot stand up. This one cannot stand up. This one can stand up for quite a long time, you see. So this is what we call having a moment of inertia. It has got angular momentum because the whole thing is fixed. There is no shakeable yolk inside. And if I now spin this and crack this, I want to crack over your head. This is hard boiled. Okay. This hard boiled we can eat. Come, eat. You have half, I have half. But we cannot crack that one, If we crack that one, let's see, Crack, Okay. Oh! Oh, this is raw. Yes! Thank you.